example, we're going to look at the enVision's Algebra 2 topic 5.3 example 6, interpreting a function and what that actually means for kind of like a real world situation. The whole reason this one was picked is because it does allow us to start seeing end behaviors and start seeing maximum and minimums in a domain and counting and looking at the left and right or the two endpoints in a certain domain for a function as a possible maximum or minimum value. So looking out to sea, the visibility in miles from a certain spot on a cliff can be calculated in a radical function. Sasha walks through elevations ranging from 5 feet to 40 feet above sea level. What is the minimum and maximum distance that she can see? So the function that they give to us is d of x, so distance with respect to x, is equal to the square root of 1.5 x. So what I would do here is you could hand graph this. We do know that I could take this apart and do this as the square root of 1.5 times the square root of x, and we would get some scaling factor, but we also do know that we're only looking from 5 to 40 feet. So what I'm going to do here is I am going to look between 5 and 40 feet. So I'm going to do 1.5 times 5 and take the square root of that. So 1.5 times 5 is going to be 7.5. And then the root of 7.5 is going to be about 2.73. Then I'm going to look at 40 times 1.5. So 1.5 times 40. 1.5 times 40. That gives me 60. And the root of 60 is going to be 7.74. Now here's the thing. The thing that I remember from radicals is they always have this type of shape. Even if they are a odd index, they still have that kind of shape, which means looking at this radical, my value here of 2.73 and my end value here at the 40 feet of 7.74 will actually be my minimum and my maximum. We have not seen radicals have a wave or kind of like a U shape in it to make a maximum minimum. They are always increasing unless it's a negative, then that's a reflection, but this is not negative. So we're always increasing. So my minimum is going to be d of x is roughly equal to 2.73, and my max is going to be d of x approximately equal to 7.75. I should have gone 7.5. This is 7.746 or something like that. So in conclusion, the maximum and minimum distances are at either end of my domain. They're at the beginning of my domain and the end of my domain. That's the min and max values. This does follow you into higher level maths, knowing to test the endpoints. We're testing the endpoints. We do know that my graph is constantly increasing because it's a radical function. In our case, it's a positive radical function, so it's constantly increasing. And therefore, the minimum is going to be the leftmost point or the end of the beginning of my domain, and the maximum will be the rightmost point or the end of my domain. Hi guys, so there you go, just a quick example on looking at the different points of a radical on the graph and interpreting what this really means. She can actually see 2.74 miles is the minimum and 7.75 miles as the maximum. And this is, again, pretty quick, pretty easy, and a great intro into looking at the ends of the domain, either end. Right, if the domain is not going on from negative infinity to infinity. So there we have it, and I will see you guys in the next lesson.